Here's our first balancing equations example. We're trying to find out how to balance the equation for the combustion of propane, which is C3H8. Combustion reactions are always going to have some sort of hydrocarbon reacting with oxygen gas to make CO2 gas and liquid water. That's going to be the standard format for combustion reactions. We're always going to have O2, CO2, and H2O in all of our combustion reactions. We're going to keep a careful count of each of the atoms on each side of the equation. As we change our coefficients, we're going to update our counts. For combustion reactions only, we're going to always do them in a particular order. We're going to balance the carbons first by putting a coefficient in front of the CO2. We're going to balance the hydrogens second by putting a coefficient in front of the water. We'll balance the oxygens last by putting a coefficient in front of the O2 molecule. Remember, save elements that are by themselves for last. First, we're going to list out how many of each atom we have on each side of the equation. We have 3 carbons, 8 hydrogens, and 2 oxygens on the left. On the right side of our equation, we have 1 carbon, 2 hydrogens, and a total of 3 oxygens. 2 of them are from the CO2, and 1 of them is from the water. Pay careful attention because some elements may appear in multiple chemical formulas in the equation. We've listed how many we have on the left and how many we have on the right. Notice that they don't match. At the end of balancing, they need to match so that the number of atoms we put in equals the number of atoms we get out. We're going to start putting our coefficients in. We'll do it for the CO2 first. We'll change the number of carbon atoms on the right to match the number of carbon atoms on the left. Right now, we have 3 carbon atoms on the left. In order to get 3 carbon atoms on the right, we need to put a 3 in front of our CO2. Now we have 3 carbon atoms on the right. When we put that coefficient in front of the CO2, it changed not only the number of carbon atoms, but also the number of oxygen atoms. Now for oxygen atoms on the right side, we have 3 times 2 is 6 from the CO2, plus 1 from the water, makes 7 oxygen atoms on the right side of our chemical equation. We're going to keep adding coefficients in and checking to see whether it's balanced or not. The next thing that we're going to change is the hydrogens by putting a coefficient in front of the water. Right now we have 8 hydrogens on the left. We need to make it have 8 hydrogens on the right. To do that, we're going to place a 4 in front of the H2O. When we do that, we end up with 8 hydrogens on the right to match our 8 hydrogens on the left. But doing that also changes our number of oxygens on the right. Now we have 3 times 2 is 6 from the CO2, and then 4 times 1 is 4 from the water, and that makes a total of 10 oxygens on the right-hand side. Now our carbons match and our hydrogens match, but our oxygens don't. The last thing we need to do is put a coefficient in front of the O2 molecule in order to make the oxygens balance. Right now we have 10 oxygens on the right, so we need to have 10 oxygens on the left. To do that, we're going to place a 5 in front of the O2 molecule. 2 times 5 gives us 10, and that matches the 10 we have on the right-hand side. Since all the counts match on the left and right sides, this is our balanced chemical equation for propane. There would be an understood 1 in front of the propane, a 5 in front of the oxygen, a 3 in front of the CO2, and a 4 in front of the water. Let's look at another example. We're trying to write the balanced chemical equation for the reaction of aqueous barium hydroxide and aqueous perchloric acid to make aqueous barium perchlorate and water. We're told in words what the reaction is, but we don't have it in symbols. You have to go back to chapter 4 and look at nomenclature again if you don't know how to write the chemical formulas from the names. Barium hydroxide is Ba parentheses OH parentheses 2. Remember, barium's in group 2A, so it has a +2 charge as an ion, and hydroxide is a polyatomic ion with a -1 charge. We need 2 hydroxide -1s to balance out the +2 of the barium. Perchloric acid is HClO4. Remember, the ic acid ending indicates that it's based on a polyatomic ion, specifically one that ends in 8. Perchlorate would be ClO4 with a -1, and there would be 1 + 1 hydrogen along with it. Barium perchlorate is Ba parentheses ClO4 parentheses 2. The barium ion is a +2, and the perchlorate ion is a -1. There are 2 perchlorate -1 ions to balance out the charge on the +2 barium. Finally, water is H2O. You need to be able to take those words and turn them into formulas. Now that we know the types of things that are in our equation, we're going to balance it. We're going to start by listing the numbers of each type on each side of the equation. We're going to keep the perchlorates together. One of our guidelines is that if a polyatomic ion appears on both sides of the equation, we're going to keep it as a single unit. The hydroxide sort of appears in the water, but not in exactly the same way. So we're going to treat the hydroxide as just oxygen and hydrogen in our counts. We have bariums, we have oxygens that are not part of the perchlorate, we have hydrogens, and we have the perchlorate ion. On our left side of the equation, we have 1 barium, we have 2 oxygens that aren't part of the perchlorate, they're part of the hydroxide. We have 3 total hydrogens, 2 of them in the hydroxide and 1 in the acid, and we have 1 perchlorate ion. On the right side for our count, we have 1 barium, we have 1 oxygen that's not part of the perchlorate, in this case it's in the water molecule, we have 2 hydrogens, and we have 2 perchlorate ions. We're going to start adding in our coefficients and update our counts. This time, because it's not a combustion reaction, we don't have our steps laid out for us. We don't have a particular order to follow. Here are a few things that help me when deciding what to do first. You will often want to balance polyatomic ions towards the beginning. If you have a 3 as the subscript of something, then you might want to do that towards the beginning as well. In this case, I look at the perchlorate and I see that I've got 2 on the right and 1 on the left. My first step is going to be balancing the perchlorates by putting a 2 in front of the perchloric acid. That updates the perchlorates, so now they're going to match. But that also updates the hydrogens. Now I have 4 total hydrogens on my left-hand side, 2 from the hydroxide and 2 from the acid. Now both barium and perchlorate are balanced. Oxygen and hydrogen are not balanced. Oxygen and hydrogen are both found in the water molecule, so all I have to do is put a number in front of the water to make the rest of the elements match up. In this case, I can put a 2 in front of H2O. That will give me a total of 2 oxygens on the right side and a total of 4 hydrogens on the right side. Now I've got 1, 2, 4, 2 on the left and 1, 2, 4, 2 on the right. Each of my atoms or polyatomic ions is balanced. My final balanced equation is 1 barium hydroxide reacting with 2 perchloric acids to make 1 barium perchlorate and 2 waters.